now we're going to change this to work one more way. And what we're going to wind up doing here is, again, every time I add an element to my top, I then go and completely redo the bottom total for all that's left. Now this is going to take more processing plus another for loop. So let's go see how that might look when we change this. Okay, I no longer need to do a running total of the bottom at the very beginning. Also, I no longer need to subtract from a bottom total. So here's how this version works. Every time I add 1 to my top total, I go in and completely redo the bottom total, which means my bottom total must start off at 0 every single time I completely redo it. So I'm going to make sure it starts off at 0, and now I'm going to do my for loop to get the bottom total. Now I don't want to start at the one I'm currently setting on, and this also means I'm going to have another index because I can't change I. So I'm going to go up here and I'm going to have K. So my K is going to be wherever I is plus 1, because I want to make sure I don't include my current element in my bottom total. Okay, so as long as K is less than my array.length K plus plus. And all I really want to do is now get my bottom total. But I got to do K. Now remember that. So now, every time I add 1 to the top, I am completely redoing the bottom total every single time. So this for loop would process positions 6 through 9 if I was sitting on position 5, if that was my active position. Now the rest of it stays the same. It's only a different way of looking at solving the same problem, just with a different twist. Now again, this one is going to take longer, so if I was really wanting to optimize my execution or my runtime, I would not do a for loop every single time I read another element from the array. So this one is going to add just a little bit versus the way we did have it. Okay, so that is the other way of processing this balanced, and that is the end of this video. I hope you learned something from both of them, or they helped you.